We have mastered AP and GP in the previous chapter, or if you feel that you haven't mastered AP and GP yet, please go back to the previous chapter. Now we are going to do other kinds of series other than AP and GP, but AP and GP will be very commonly used over here. Okay, so for a start, let's do some recap. The UN for any AP is A plus D bracket n minus 1. The UN for any GP is A r to the power of n minus 1. Okay, and the sum of AP, you have to know all this, is n over 2, 2a plus d bracket n minus 1, or if you're okay and you understand how to use n over 2a plus l, then go ahead to use it. If you're not sure, please refer to the previous chapter first. Sum of GP is a 1 minus r power n over 1 minus r. And we also have the sum of infinity for GP, which is a over 1 minus r. Now, next part, we are going to understand how to use this notation called the sigma sign. So this is called the sigma sign. Sigma sign is to sum something, okay, is to add up something. So as I put over here on the top, a series is a sum of the sequence. If I do have a sigma sign like this, this is the starting R. The starting R where R could take. Okay, usually it starts with 0, it starts with or, it starts with 1. Later I'll explain further. And this is the last term that R could take, okay, or the last value of R that it takes, the highest one. Okay, now what does this mean? So remember that, okay, U1, U2, U3, U4, these are all sequences. A sequence is a set of numbers with a certain relationship with them, between them. Okay, now a series, if I want to sum U1 plus U2 plus U3 plus U4, in the previous chapter, we put it as S4, the sum of the first 4 terms. Okay, so in this chapter, where we are going to introduce a summation sign, is the same as saying the summation of UR. Okay, this guy is always in terms of R. The first is U1, right? So I say R equals to 1. It starts with U1. And it ends with 4. Yeah. So this summation sign over here with R equals to 1 to 4 means that I start at U1 plus, summation means at, plus U2 plus U3 plus U4. Or it has the same meaning as S4. So this is how we use summation. Over here, it's always the sequence, because a series is a sum of sequences. Okay, yeah, so essentially, if you know how to read it in terms of k and n, it means this way. It also just means that if I want to sum from r equals to 3 to, let's say, 7 of ur, it means u3 plus u4. Now, the r will always increase by 1. The increment is always by 1. Plus u5 plus u6 plus u7. That's all. Okay, can? Over here at the bottom, all of these are just things that I talked about. Sn is the same as u1 plus until un. If I put into summation, it looks like this. S infinity means I replace the n with infinity. The n becomes infinity. Okay, and if you understand how to use limits, this is the same way as writing, but we will cover this in some examples behind. Okay, this number 3 is very important. U1 is the same as sum of one term. This we already covered in the previous chapter. So to get Un is the sum of Sn minus the sum of Sn minus 1. It's the same thing as if for example, if I have the sum of 29 from r equals to 1 to 29 of ur, okay, minus the sum of r equals to 1 to 28 of ur. What am I getting? So in layman terms, the first guy is u1 plus all the way until u29. Minus the second one is u1 plus all the way to 28, u28. Maybe I write over here, before u29 is u28, right? Yeah. So you are minusing off all the first 28 terms. What are you going to left with? Just u29, the u29th term. Okay, so this concept still holds in this chapter, whatever we are going to do. Okay? The use of summation and the properties of summation. Okay, so number one, the number of terms is n minus m plus 1. So where does n minus n comes from? So basically this is a very easy way of finding out how many terms are there. So you look at the top, this is the n, this is the top number minus the bottom number, then plus 1, okay, plus 1. Now how does this sounds like? It's because let's say I have r equals to 1 to 5, okay, of ur. I know it's the sum of u1 plus u2 plus u3 plus u4 plus u5. How many terms are there? There are 5 terms. Okay, so how to get this 5 from this number here and this number here? So the number of terms is equals to 5 minus 1 plus 1, which of course I know is 5 lah. Like from 1 to 5 I know there's 5, right? Yeah. But if something gets more complicated like this, r equals to 7, from 7 to 39, ur. Of course I know I minus off, okay, I'm going to get 32. So many students make the mistake of 32. Okay, so this is u7 plus all the way plus until u39. But in order to calculate the number of terms, this only tells you the number of terms. Okay, the number of terms, the number of sequences that we add up is 39 minus 7, that gives you 32, right? Plus 1. Because when you count 7 to 39, right, there are actually 33 terms. Okay, over there. So the top minus bottom plus 1 is actually a easy way of calculating how many terms are there. Okay, so and then if you look at number 2, down here, that talks about, okay, the sum of C. What is C? C is a constant. The sum of C is just the number of terms multiplied by C. What does this mean? Let's say if I want to sum of, I'm just going to use r equals to 1 to 5 of a certain value, let's say 2. Okay, so what does this mean? This means I'm going to add 2 plus 2 plus 2 plus 2 plus 2 5 times, because u1 is 2, u2 is still 2, u3 is still 2, u4 is still 2, and u5 is still 2. Okay, so in layman terms, this is just going to be 5 times of 2, isn't it? Which is 10 lah, yeah. But in a more systematic way, we're just going to use the number of terms, which is 5 minus 1 plus 1, top minus bottom, then plus 1, multiplied by the constant here. And that's how I got this 10. Okay? If I put it in terms of a constant, so for example, n, yeah, r equals to 1. This is something that students always make mistake in. Okay? And I want to count to n. This is something more tricky. Okay? It's going to be, now remember that n is a constant. It doesn't increase. Only r increase in this chapter. Okay? So what does this mean? The n I put on the outside. Okay? u1 plus u2 plus u3 plus all the way until plus un. And all these terms, and because it's a sum of constant, all these terms is n, or n. Okay? So to understand this, the n I put on the outside, this n comes from this n, the n I put on the outside. Okay? And because it's a sum of constant, right, I apply this. Top minus bottom plus 1. Okay? And then the final answer is n squared. Okay, so the sum of constant, it is something that you have to be, okay, very sure about. Next, I'm going to talk about another property of the summation, which is if I want to sum of r equals to, okay, usually like I said, the starting position is 1, right? If I don't start at 1, or from 4 to 10, okay, ur. The best way of doing this is always try to start from 1. That means if I start r equals to 1 of ur, minus away the sum of r equals to 1 to 3 of ur. Does it make sense? It makes sense because this guy is called u1 plus all the way until u10. This guy is called u1 plus all the way until u3. Okay? Because I only want u4 plus u5 until u10. I don't want u1 to u3. So that's why the sum from 4 to 10 is the same as the sum from 1 to 10 minus the sum from 1 to 3. Okay, putting it in terms of n is more tricky. Like if I want the sum of r equals to n plus 1 to 2n of ur. This is something actually quite common. Okay, it's the same as the sum of r equals to 1 to 2n of ur minus the sum of r equals to 1 to n of ur. Why is this so? Because 1 to 2n is the same as u1 plus u2 plus u3 plus until in the middle is called un. After un is called un plus 1. Yeah. And then un plus 1 will keep on adding until un plus n, which becomes u2n. Okay? This is called the summation from u1 to u2n. Okay? Minus of, this is just the concept part. Okay? You have to understand this part. u1 plus all the way until plus un, which essentially means I'm taking off away here from here. What am I left with? un plus 1 to u, okay, 2n. So this is a concept that you must be very familiar with. Okay, another concept, which is concept number 4, and building up to concept number 4, right? Yeah, I'm going to talk about a few things as well. That means if, let's say, I have the sum of r equals to 1 up to n of 2r, okay, I can always take out the 2 here and do a summation of r equals to 1 to n of r. Okay, yeah. Now we are talking about how to identify this. Okay, so this guy, the one that is in red, to split up the summation, that means open up the summation. Now I put r equals to 1. That's 1. Okay, next, r equals to 2. Now a summation means plus, plus 2, plus 3, plus 4, and so on until plus n. You have to identify that this guy over here is actually a AP because each of the sequences adds up by 1. The A is equals to 1. The L is equals to n. Okay? And there are n terms over here. Okay? So that's why this guy, I can say that it is a AP of n over 2. First term, A, plus L, last term, 1. Okay, and this is how I break up a summation into a, open it up and then identify that it's an AP and then put it in the general formula. So the final answer for this is n plus 1. Okay, so with this, you must also understand that if my top values changes, right, okay, the things inside my n will also change. Meaning to say that, we already found that when r equals to 1 of 2r is equals to n bracket n plus 1. Okay? If I'm going to change this guy to become 2n, r equals to 1, 2r. Can see? This n becomes 2n here. All my n is going to become 2n. 2n bracket 2n plus 1. Can see over here, this guy becomes 2n, this n becomes 2n. Okay, so this is also another important concept. Even if I change this to become n plus 1, summation of r equals to 1, 2r. Basically, my n just becomes n plus 1. So look at the first line. This will become n plus 1 times n plus 2. Okay, take this to replace the n with n plus 1 and the n to replace with n. Both n's replaced with n plus 1, and then this is how we get a properties, okay, with regards to, okay, this. And the last property is talking about if you have the same summation sign for two terms that is plus and minus, you can split up these two terms. Okay, so over here there are 4 sequences, okay, that is very common. The first one is an AP, which you must know. Okay, which you must know. The summation of r is always an AP. And the last one, anything to the power of r, is always a GP. Okay, even if you cannot identify, you just need to list them out. Later I will show you some examples. Okay, and then you will be able to see. Okay, and then these two are usually given. Okay, and usually given. And all these properties, okay, are important. So make sure you understand this table and what is this table talking about, especially for point number 2, the summation of constant. Point number 3, if you are taking the R from somewhere else in between, okay, how to minus off. Yeah, and then one more is when I say that when your ending point becomes from n to 2n, you replace the n with 2n. If the ending point becomes n plus 1, you replace the n with n plus 1.